Thank you for click on this video. I sajal.sasmal welcome you to complete lecture series of solar photovoltaics. Please click on description for playlist of complete solar cell tutorial. Let's start. The wide range of semiconductor applications comes from the ability to easily change their conductivity. The addition of even very small amounts of impurities, known as dopants, can change their material conductivity over orders of magnitude even though the impurity concentration might be very small with concentrations of the order of parts per billion. The conductivity may also be changed by applying a voltage or current in one part of the materials to cause a large change in the conductivity in another part of the device. Solar cells are usually based around PN junction devices and are just large diodes that have been optimized to absorb light. As such, solar cells belong to the family of bipolar junction devices, which also includes diodes and bipolar junction transistors (BJTs). Semiconductors typically use the CGS centimeter, gram, second unit system. However, the thickness of a solar cell will be measured in microns. For modeling and calculations, the easiest approach is to convert all dimensions to cm so that a wafer of thickness 160 micrometers becomes 0.016 centimeters. Semiconductor materials. Overview. Semiconductor materials come from different groups in the periodic table, yet share certain similarities. The properties of the semiconductor material are related to their atomic characteristics and change from group to group. Researchers and designers take advantage of these differences to improve the design and choose the optimal material for a PV application. The atoms in a semiconductor are materials from either group IV of the periodic table, or from a combination of group 3 and group V, called EV semiconductors, or of combinations from group 2 and group V, called EV semiconductors. Because different semiconductors are made up of elements from different groups in the periodic table, properties vary between semiconductors. Silicon, which is a group IV, is the most commonly used semiconductor material as it forms the basis for integrated circuit (IC) chips and is the most mature technology, and most solar cells are also silicon-based. A section from the periodic table. More common semiconductor materials are shown in blue. A semiconductor can be either of a single element, such as silicon or germanium, a compound, such as gallium arsenide, indium phosphide or cadmium telluride, or an alloy, such as silicon x germanium 1x or aluminum x gallium 1x, as, where x is the fraction of the particular element and ranges from 0 to 1. Thank you for watching the video. Please like and share this video. I will be so happy if you subscribe my YouTube channel. Click on description for playlist of complete solar cell tutorial.